Hello, you should have out your Section 7 notes, Similarity and Transformations. We are going to continue to look at this idea of similarity, but today we're going to look at what a dilation is. So starting out, a dilation with a scale factor of k greater than 0. So k is the variable used to denote a scale factor. And center 0, 0. So we will be centered around our origin as we work through this. A scale factor of k greater than 0 maps any ordered pair xy to some other ordered pair where it's the scale factor times x and the scale factor times y. Okay, so let's just say we call k equal to 5. That's the scale factor of 5. And so if we were going to have any ordered pair, let's just say randomly 1, 2. Any ordered pair that when it goes through a scale factor of 5 will be, each number will get multiplied by 5, exactly how it's shown right here. So my new ordered pairs would be 5, 10. Okay? Or, kind of make a separate line here, let's say our scale factor is smaller than 1. So let's just go with a half. So if we were to work with the numbers or the ordered pair 10, 5, then with a scale factor of 1/2, we would multiply each ordered pair by a half. So our new point would be 5, 2.5. Okay, so when you look at your scale factor, it can tell you whether your shape becomes larger or smaller. If the number is greater than 1, such as this one 5, it's going to be 5 times as large. In this case, if my scale factor was a half, it's going to be half the size of your original point. And then this sentence right here, a dilation with scale factor k and center of 0, 0 will be described using this kind of pathway. So we will rewrite this entire line right here as we describe our transformations or dilations. So let's look at a couple examples here. Apply the dilation D to the polygon with the given vertices. Describe the dilation. So, example 1, the dilation is right here. For every xy, it will be dilated 3 times x, 3 times y. So, our original ordered pairs are A, B, and C. So, I'm going to outline, there's a lot of lines on this graph. So, go ahead and kind of outline that triangle. Now, if you have some different colors, you might pause this video and grab your colors to work with. So here are my ordered pairs, 1, 1, 3, 1, and then 3, 2. So what I want to do here is go with the dilation, and I want to write out A prime, B prime, and C prime. And when I do that, I'm going to actually take each number and run it through the dilation. So I'm going to multiply x by 3 and y by 3. So my new ordered pair with 1, 1 will be 3, 3. Moving on to B, when I plug in my 3 times 3 will be 9. And then the y is a 1. 1 times 3 is 3. And then C, plugging in 3 times 3 is 9. And then plugging in 2, 3 times 2 is 6. So if you look, and I'm actually going to change colors here, A prime, B prime, C prime on my graph is already here. A prime, B prime, C prime is this larger triangle right here. Make that a little darker. And so these 3 ordered pairs actually match what is graphed. Okay, so when we describe it, so we just applied the dilation right here. Now, describing it, so I'm going to write here, describe. So when we describe it, we're going to say this is a dilation with scale factor. A dilation with scale factor of 3, and I got that from my directions right here in the problem. A dilation with scale factor of 3 centered at 0, 0. And like I said, we will be centering our dilations at 0, 0. Okay, if you want to try to pause it and try to move on to number 2, go ahead and do that. That way you can get a head start on it. So go ahead and pause it here. You're going to do the same thing. Don't look at the picture right now. I want you to run through this dilation with your ordered pairs and then describe it. Okay, example 2 here. When I go through this dilation, I'm going to multiply each ordered pair by 3/4. So first of all, I'm going to outline P, Q, and R. P, Q, where is... looks like I have... Looks like there's a typo here. This says Q, it should say R. So there's my triangle right there. Oops. Okay, so when I go through each ordered pair, P prime, I'm going to take -8, and you can do it on a calculator, or you can do it out by hand pretty quick. I'm going to take -8/1 and multiply it times 3/4. And when I do that, I can actually cross cancel. 4 goes into 4 once. 4 goes into -8, of course, -2 times. So when I multiply, actually that would be negative. -2 times 3 is -6. 1 times 1 is 1. So it was going to be at -6. And when I run a 4 through here, I do 4/1 times 3/4. Look at how my 4's just cancel out to be 1s. So the answer is -6/3. Q prime. -4. Well, I know +4 turned out to be 3, so -4 turns out to be -3. And when I run 8 through, I will get a +6. And R will be, 4 will end up being 3. R prime, excuse me. Okay, so let's look at those. P prime is right here, and that was what I calculated at -6/3. Q prime is right here at -3/6. And then change that Q, this other Q, to an R. Looks like a typo there. So that's going to be at 3/3. So I'm going to outline this triangle. So when I describe it, so I'm going to write here describe. This is a dilation with scale factor. A dilation with scale factor, and my scale factor is right here. It's the number I've been multiplying everything by scale factor of 3/4, centered at 0, 0. Now, one thing I want you to pay attention to that I didn't really mention a second ago, back to number 1. My triangle, the original one was blue, went from blue to yellow, so it became larger, and my scale factor is 3. It's a number bigger than 1. My second example, the blue triangle was the first triangle. It became smaller, and my scale factor is a number smaller than 1. So when you work with numbers, when you multiply by numbers bigger than 1, you get a bigger number. When you multiply by numbers smaller than 1, you get a smaller number. All right, let's move on to number 3. Okay. Number 3 says we want to determine whether the polygons with the given vertices are similar. So we've got A, B, C, D. So there's A, B, C, D. I'm going to go ahead and outline it in blue. Okay, and then my second one here, H, J, K, L, H, J, K, L. Now, in order to be similar from what we talked about in the prior section, in order to be similar, I need to have shapes where the corresponding angles are congruent and the sides are proportional. So I can tell on this graph, these are right angles right here. I've got a horizontal, vertical line. So these 4 corresponding angles are all 90. So I don't really need to check through that, but I do need to see if the sides are proportional. So I'm going to compare sides that are corresponding. So I'm going to say here step 1, I'm going to say here angles are congruent, just to show that I thought about that. So step 2, I need to check my sides. So I'm going to first start with A compared with, where's A at? A compared with H. Okay, these are, I guess, point A. Let me back up a second. We want the side lengths to be proportional, but when we are on a coordinate plane, we are going to compare their ordered pairs because their ordered pairs give us information about the sides when they're connected. So I'm going to start with point A and compare it to point H. So A is the ordered pair -6, -6. H is the ordered pair of -2, -2. So we want to look at the comparison between those numbers. Now when I look at this picture, my blue triangle is reducing in size. So I'm going to write here, first of all, it's a reduction. So I can tell the relationship between the 6 and the 2, or the -6 and the -2, is a multiple of either 3 or a third. And since my shape is getting smaller, it is going to be a 1/3. And so I can always start with my new shape divided by my original. If you need a pathway or you need some sort of formula, you could do that. -2 over -6 is equal to a third. So I must have this same factor everywhere in order for it to be similar. Okay, so let's check. Point B is -6, 3. Point B here on the graph corresponds to J. J is -2, 1. So let's compare. -6 to -2, that's dividing by 3. 3 dividing by 3 is 1. So that does equal a third again. C is 3, 3, and K is 1, 1. 3 divided by 3 is a third. So 3 divided by 3 is 1, which again reinforces my third. Let's check the last one. D, 3, -6. L is 1, 2. So 3 divided by 3 gives me 1. -6 divided by 3 does give me 2. Okay, so because I get the same factor, I would say yes. Shapes are similar. And so I am going to determine if they're similar. So I'm going to write out the dilation. So I'm going to say for every ordered pair XY, it is mapped onto 1/3 X, 1/3 Y. So this is how I'm answering this question. So to determine if they are similar, so let's go back to see what the directions were. Determine if they're similar. They are similar if the corresponding angles are congruent, and then when I compare all their corresponding ordered pairs, if they are also moving by the same factor. Okay, let's move on. All right, next example here. What I'd like you to do is go ahead and pause this and see if you can replicate what we just did and determine if you believe these shapes are similar. Okay, so go ahead and pause this and then come back here when you've had a chance to get started. Okay, when I look at this problem again, I see two rectangles, and so I can tell that these are 90-degree angles, so I don't have to worry about checking angles, but I do want to check ordered pairs. So I'm going to compare P over here to W. So when I compare P, which is 2, 0, to W, which is 5, 0, now I can tell that my shape is getting larger. So in order to, if I wanted a formula, I would do second shape divided by first. So if I check this out, I have a 5 divided by 2 type of a factor, because I can take the 5 and then divide it by 2. So I can leave it as 5 divided by 2. I can write it as a 2.5. Okay. So let's check now Q to X. So Q is 2, 4. X is here at 5, 10. So if I look at this, I have 5 over 2. Okay. which is 2.5. And I have 10 over 4, which is also 2.5. So it looks okay so far. Let's check R to Y. So R is at 4, 4. Y is at 8, 10. So if I do 8 divided by 4, I get 2, which is different. So I can stop right here, and I can say not similar. And then I might say something like, different scale factors. Different scale factors. Now, when I go back here to the very beginning, I probably could have noticed it right here. 0 divided by 0. So if you go ahead and do 0 divided by 0, oops. Let me key that in. 0 divided by, so when you divide anything by 0, you get a divide by 0 error or a syntax error. You cannot divide by 0. So I probably could have stopped right there and said, hey, I didn't get 2.5, therefore they're not similar. Okay, let's keep going. Number 5 here. Number 5 is a very similar type question. Determine if the polygons are similar. But if you look at your picture, I see 3 polygons. So I've got ABC is the original polygon right here, ABC. In fact, I'm going to put a number 1 right there. And then DEF is actually right here. So look at my A prime, B prime, C prime. That's actually going to happen next. And then I'm going to see if it actually moves on to 3. So I need to determine how did my first triangle transform to my second, and is my second one going to be similar to my third one? So when I look at that and I see the same size triangle, it's either a reflection, a rotation, or a translation. And when I investigate a little closer, A and A are still on the bottom left, B to B prime bottom right, C to C prime top right. So it can't be a rotation or a reflection. So this is a translation. So step 1, I'm going to say here that triangle ABC is translated to A prime, B prime, C prime. And so I'm going to describe the translation. We can use a vector. Let's start with a vector and then I'll show you the other way. So this move, my vectors should tell me the X movement and the Y movement. So it went to the right. So it moved over 1, so that would be a positive 1, and then it moved down. 1, 2, 3, 4, 5. Okay, there's my vector, or I could describe it with coordinate notation. Every x, y mapped onto x plus 1, comma y minus 5. Either one of these will say that it was a translation. Okay, now I need to look at the, obviously this became larger, so this is probably a dilation, only if it's similar. So I'm going to write my ordered pairs down. We've got A prime is at 2, negative 3. B prime is at 3, negative 3. C prime is at 2, negative 1. So I want to see, do I have, like I did up here in example 2, are my scale factors the same? So A prime is going to correspond to D. So D is at 4, negative 6. So I'm going to write them all out so I can look at the numbers and compare. B corresponds with E, 6, negative 6. C corresponds with F. So now I want to see, obviously it's getting bigger, so it's multiplying by a number bigger than 1. Do I have the same number? Well, 2 up to 4, that looks like times 2. Negative 3 up to negative 6, that's also times 2. So let's see if it's times 2 all the way down. 3 to 6, yes, times 2. Negative 3 to negative 6, times 2. 2 to 4, negative 1 to 2. So that is my scale factor right there, 2. So I can say that triangle A prime, B prime, C prime is dilated, or we can say is a dilation, to triangle DEF. And then I'm going to describe the dilation with this coordinate notation. So for every x, y, it was mapped onto 2x, comma, 2y. Okay, I'm going to do the last example. If you feel like you got the hang of it, you can go ahead and get started on your assignment. Last example, we're going to do the same thing. I'm starting with F, G, H, and J, which is right here, number 1. I'm ending with S, T, U, and V, which is this smaller one. So 1 somehow transformed to 2, which then transformed to 3. So when I look at 1 to 2, I need to determine what's going on. So compare your ordered pairs. G, G prime is right over here. H, H prime is right across from it. F to F prime, right across. J to J prime. So this looks like a reflection to me. It was reflected over the line or the y-axis. So, excuse me, let's say here F, G, H, J is reflected. I'm going to add the line of reflection over the y-axis to F prime, G prime, H prime, J prime. F prime, G prime, H prime, J prime. Okay? So then to go from 2 to 3, let's check our dilation. It looks like a dilation and it's getting bigger. So F prime is at F prime here. Looks like it's at negative, what is that, 3? 1, 2, 3. Negative 3, 3. I need G prime, H prime, J prime. So go ahead and write those out. I'm going to write them out at the same time. G is at negative 3, 6. H prime, negative 9, 3. And then J appears to be at negative 9, negative 3. So let's check our scale factor. Let's see. F corresponds with S. S is located at negative 1, 1. T corresponds with G, negative 1, 2. U right here is at negative 3, 1. And then V, negative 3, negative 1. All right, so if it's getting smaller, I would expect it to divide by the same number or multiply by some sort of fraction. So let's compare number to number. Negative 3 to negative 1 looks like divided by 3. 3 to 1 divided by 3. Another 3 to 1. How about 6 to 2? That is a divided by 3. Negative 9, negative 3 divided by 3. Looks like divided by 3. Let's check the last 3. Yes. So we could say divided by 3. It's also multiplied by a third. So I'm going to say here dilation, and let's write the coordinate notation. Every xy is dilated or transformed. It's going to be 1/3 x times 1/3 y. So what I want you to do on the assignment is go ahead and look for these similar examples. If you're on a coordinate plane, then you're going to check the dots. Back to the first examples, if you are given the dilation, well, you're just going to run it through and multiply by each ordered pair.